Hello everybody, this is Mr. Poley coming at you with the day 11 assignment for applications of statistics. I'm here to inspire you today. Okay, it is Sunday, April 26th at 4:30 in the afternoon on a beautifully cloudy and slightly rainy day. Hope you guys are staying safe, maybe getting some exercise in, enjoying the fresh air, even if it is raining a little bit. But I hope everybody is staying safe and continuing to stay busy and productive. So I am going to read this assignment for everybody. Again, this assignment is due on Wednesday, April 29th, so that is 3 days from now. I will be posting this video Monday morning, so it will be due 2 days from then. Due before our Zoom call so that we can go over these questions and get a little discussion going during that Zoom call. So please make sure you have this assignment done by Wednesday at 1 p.m., I believe, is the time of our Zoom call. So keep that in mind. Okay, here we go. Reading the assignment due Wednesday, 4/29, day 11. Towards the beginning of the coronavirus outbreak, a possible model was released for the number of coronavirus cases over time with and without protective measures and other interventions in place. This was a very important visual when it was released because at the time nobody really knew what to expect. We could only do our best to rely on the predictions of so-called experts. With that said, it's not enough to trust everything you see for what it is. You need to take the time to think about what it is you're reading or looking at and make sense of it through a deeper level of thinking. Okay, that might involve putting your thinking cap on a little tighter. So this will set you up to be better informed and a more connected member of society. And who doesn't want that? Exactly. So for this assignment, I want you to view the model, the one I mentioned in the beginning about the coronavirus cases over time. So view the model that is attached in the assignment section and respond to these 3 prompts. Okay, so I right now have a dual computer system set up. I'm recording on my Chromebook and on my old MacBook. You see there's the model that I want everybody to be viewing. Okay, and everyone's going to go through the same process. There's 3 steps here. Okay, what do you notice? What do you notice about the model? It's really just looking at it, making some observations. If you try to make a claim, perhaps tell us what you notice that supports your claim. Got to have some kind of justification there. Okay, but that should strictly be what you notice. So what can you see? What can you observe on that graph, on that model? Then once you've noticed things, what do you wonder? What are you really curious about that has you itching to learn more? Okay, so you notice things first, then maybe the things you notice start to make you curious about something else. So think about what you wonder there. What do you wonder about that graph? Then the final step, what is really going on in this graph? Okay, that's the whole idea here. Figuring out what you notice, thinking about what you wonder, then try to put that all together to figure out what's really going on here. So for this last step, you have to come up with a catchy headline that does the best at capturing the main idea of the visual. Okay? So after I go through that process for everybody, there's a few more questions that I want everyone to think critically about and answer independently in at least a few sentences each. I'll read those after I go through this first process. But those other questions will be up to you guys to come up with your own answers, again, so we can have a little discussion on those during the Zoom call. Okay, so again, back to the beginning of the process. First thing, who remembers what I asked you guys to do first? That's right, what do you notice? So I'm going to take a minute to look at my model over here and really think about what I notice. So, first thing that comes to my eye, I notice 1 red curve and 1 blue curve. Right? And of course, going a little further into that, the red curve says without protective measures, and the blue curve says with protective measures. Okay, I also noticed that the blue curve peaks at a dotted line labeled healthcare system capacity. Right, the peak is that maximum point where that curve, the highest point that curve goes up to. Right, again, that blue curve is right at a dotted line that says healthcare system capacity. Another thing I noticed on that same idea is that the red curve goes beyond that dotted line. The red curve peaks above the line labeled healthcare system capacity. So again, that's just something I noticed. I'm not trying to get any deeper into that right now, but maybe I can come back to that with something I wonder. Okay, what else do I notice? Well, I'm going to go out on a limb here and make a claim, because as a mathematician, I can do that. So I'm looking at the x and y axes, and I see that the y-axis is labeled number of cases, and the x-axis is labeled time since first case. So this tells me then that the number of cases depends on the time since the first case. Right? And doesn't that make sense? As time goes on, there's going to be more cases. More cases will come about as time passes. So the number of cases totally depends on the time since the first case. So the time since the first case is your independent variable here, your x variable, and the number of cases is your dependent variable or your y variable. All right, again, just something I noticed, and I was able to make a claim based on that noticing. So, now that we've noticed things, what do we do next? Do we just go on our way and say, great, I noticed that, let's move on? Absolutely not. Now it's time to wonder, okay, what am I really curious about that has me itching to learn more? Well, based on the first thing I noticed, when I said there's one red curve and one blue curve, I wonder if the makers of this graph, says it was adapted from the CDC and The Economist, I wonder if they made that red one red on purpose, because normally when you see red, it's associated with bad things, negative things, sometimes danger. So that one's red and it says without protective measures, and the one that's blue, again, says with protective measures. So I just wonder if that was really intentional. The red was good, red was bad, blue was good. All right, something I wonder there. I also wonder, since this model was released early on, over a month ago now, I wonder what our current model, how does that compare to these two? Do you think we're somewhere in the middle? Are we still under that healthcare system capacity line? I hope so, right? But that's what I wonder, and I can probably do some Google searching and figure that out. But again, that's something I wonder, and I'm curious to learn more. So I probably will look into that later. I also wonder, if this were to happen again, how might this model look different? Because you think, would the curves be lower because it's something we as a society have experienced before, so we're able to right off the bat keep those curves lower? Or would that dotted line, the healthcare system capacity, would that be higher? Right? Hopefully, since we know how bad the situation got, maybe they'll better equip the healthcare system. Right, raise that capacity so they could handle more cases if, hopefully not, but if something like this were to happen again. All right, so again, just a few things that I'm wondering that could lead me to further look into this. All right, that's not part of the assignment, but I wouldn't hold it against you if you did that. Okay, so last thing. Again, we noticed things. The things we noticed got us wondering things. So now it's time to answer, I guess not really answer fully, but to think about a little bit more what's really going on in this graph. Okay, you got to come up with a catchy headline here that does the best at capturing the main idea. So I came up with one, which I'm going to share that one with you, but I didn't want to do more because I want to see what you guys can come up with. So this could really bring out some creativity here and really kind of, it'll be cool, I think, to compare what we each came up with. So mine, again, the colors were just jumping out at me. So my headline is red versus blue. Which coronavirus model will prevail? Right? I think that's pretty catchy. I mean, I came up with it, so of course I'm going to say that. But I think that does a good job at capturing the main idea, right? Red and blue curves, one's without protective measures, one is with. Which one of those will prevail, right? Only time will tell. Of course, time is independent. All these cases depend on the time. So we'll have to wait to see. But do your best, everybody out there who's watching this, everybody in applications of statistics, maybe some other people, if you stumble across this video and you want to give it a whirl, walk through that process. Take your time with it. Don't just give me one-word answers. Okay, I want to know what you notice. Really take 5-10 minutes. Think about that. Okay, then what do you wonder? What are you curious about? What do you want to learn more about? What can you maybe pose to our Zoom call and have us all scrambling to figure out and to research? Okay, and then what is really going on? Again, come up with that catchy headline that does the best to capture the main idea. Okay, 3 steps there. I want to hear some nice, thoughtful, reflective answers and responses. Okay, can't wait to talk about this with everybody. But there is a second part to this assignment. Those 3 questions that I said I wanted you to think critically about and answer independently in at least a few sentences each. Again, we will discuss all this during the Zoom call, so please make sure you have these questions answered beforehand. Okay? Number 1, by implementing protective measures like social distancing and closures of schools and businesses, why would the number of cases at any one time decrease compared to when there are no protective measures? Why would the length of the epidemic increase when protective measures are implemented? Okay? Think about that critically. Give it some time to simmer in there and come up with a few sentence response. Okay, number 2. What interventions could be instituted to change the outcomes shown in this graph? Break down your response into what could change the length of the epidemic, the number of infected people, and the number of infected patients that could be treated. Which of these changes would be easiest, and which do you think would be hardest to implement? Okay, and please give me more than just the name of the change, but give a reason why you think it would be easier or harder to implement them. Okay, and the last one, number 3. A simulation is a mathematical process that models random events. A random event is an event that is not predictable. That is, you cannot predict its occurrence exactly. Right? It's random. We don't know when it's going to happen. So good simulations closely resemble real-world outcomes. The Washington Post published a simulation, which the simulation is linked under the assignment. They published a simulation of the spread of the coronavirus under 4 levels of intervention. No intervention, forced quarantine, and 2 levels of social distancing. In the dynamic simulation, you can see the infected members of the population interacting with others, either by staying clear of others or infecting them. The simulations show how the number of healthy, recovered, and sick individuals changes over time. So view the article and see the results of these 4 levels of intervention. Are the curves in the graphs based on the simulations symmetrical as they are in the New York Times graph? If not, why do you think they are not symmetrical? Based on what you see in the simulations, what amount of intervention do you support? Okay, so that last question there, that is your opinion. After looking at the 4, looking at the simulation, which one of those 4 do you personally support? And of course, be ready to back that up. Why do you support it? Okay, and just as one little vocab word, just to make sure, they were talking about the simulations being symmetrical. So who can tell me, who can remind us all, what does it mean to be symmetrical? What do you think? Okay, no, my face is not symmetrical. I heard that. It's one of the first things maybe you learn in art class, that nobody's face is perfectly symmetrical. And why not? Well, look at that. I have a mole right there, not over here. If I was symmetrical, I'd be identical on the left side to what I am on the right side. So symmetrical, think you're looking in the mirror. It's perfectly the same on one side as it is on the other. Okay, just a little vocab that will help you out. All right, so I think that brings me to the end of that assignment. I walked through the process. Now it's your turn. And then, of course, you have to answer those critical thinking questions at the end. And boy, am I excited to discuss this with everybody on Wednesday. I can hardly wait. Hope you guys are excited too. Do your best with this. Have some fun with it. And as always, love math. Mr. Poley out of here. See you next time.